Chapter 2. The Planet Earth. The planet Earth has a stony shell, the lithosphere. It consists of igneous rock like granite and basalt with sedimentary rock on top. The igneous rock is the original crust of the Earth. The sedimentary rock is deposited by water. The inner composition of the Earth is not known. The propagation of seismic waves gives support to the assumption that the shell of the Earth is over 2,000 miles thick on the basis of the gravitational effect of mountain masses, the theory of isostasy. The shell is estimated to be only 60 miles thick. The presence of iron in the shell of the migration of heavy metals from the core to the shell has not been sufficiently explained. For these metals have left the core, they must have been ejected by explosions, and in order to remain spread through the crust, the explosions must have been followed immediately by cooling. If in the beginning the planet was a hot conglomerate of elements, as the nebular as well as the tidal theories assume, then the iron of the globe should have become oxidized and combined with all available oxygen. For some unknown reason, this did not take place, thus the presence of oxygen in the terrestrial atmosphere is unexplained. The water of the oceans contains a large amount of soluble sodium chloride, common salt. Sodium might have come from rocks eroded by rain, but rocks are poor in chlorine, and the proportion of sodium and chlorine in seawater calls for 50 times more chlorine in the igneous rock than it actually contains. The deep strata of igneous rock contains no signs of fossil life. Encased in sedimentary rock are skeletons of marine and land animals, often in many layers, one upon the other. Not infrequently, igneous rock is found protruding into sedimentary rock or even covering it over large areas, pointing to successive eruptions of igneous rock that became heated and molten after there was life on the Earth. Upon strata which show no signs of fossil life, our strata contain shells, and sometimes the shells are so numerous as to constitute the entire mass of the rock. They are often found in the hardest rock. Higher strata contain skeletons of land animals, often of extinct species, and not infrequently above the strata with the remains of land animal are other strata with marine fauna. The species of the animals and even their genera change with the strata. The strata often assume an oblique position, sometimes being almost vertical. Frequently they are faulted and overturned in many ways. Cuvier, 1769 to 1832, the founder of vertebrate paleontology, or the science of petrified skeletons of animals possessing vertebrae from fish to man, was much impressed by the picture presented by the sequence of the layers of Earth. When the traveler passes over these fertile plains where gently flowing streams nourish in their cause an abundant vegetation, and where the soil inhabited by numerous population adorned with flourishing villages, opulent cities, and superb monuments is never disturbed except by the ravages of war or by the oppression of the powerful, he is not led to suspect that nature also has had her intestine wars, and the surface of the globe has been broken up by revolutions and catastrophes. But his ideas change as soon as he digs into that soil which now presents so peaceful an aspect. Cuvier thought the great catastrophes had taken place on this earth, repeatedly changing seabeds into continents and continents into seabeds. He held that genera and species were unchangeable since creation, but observing different animal remains in various levels of Earth, he concluded that catastrophes must have annihilated life in vast areas, leaving the ground for other forms of life. Where did these other genera come from? Either they were newly created, or more likely they migrated from other parts of the world which were not at that time also visited by cataclysms. He could not find the cause of these cataclysms. He saw in their traces the problem in geology is of the most importance to solve, but he realized that in order to resolve it satisfactorily, it would be necessary to discover the cause of these events, an undertaking which presents a difficulty of quite a different kind. He knew only of many fruitless attempts already made, and he did not find himself able to offer a solution. These ideas have haunted, I may almost say have tormented me during my researches among fossil bones. Cuvier's theory of stabilized forms of life and of annihilating catastrophes was supplanted by a theory of evolution in geology, Lyell, and biology, Darwin. The mountains are what is left of plateaus eroded by wind and water in a very slow process. Sedimentary rock is detritus of igneous rock eroded by rain, then carried to sea and there slowly deposited. Skeletons of birds and of land animals in these rocks are presumed to have belonged to animals that waded close to the shore of the sea in shallow water, died while wading, and were covered by sediment before fish destroyed the cadavers or the water separated the bones from the skeletons. No widespread catastrophes disrupted the slow and steady process. The theory of evolution, which can be traced to Aristotle and which was the teaching of Lamarck in the days of Cuvier and of Darwin after him, has been generally accepted as truth by natural sciences for almost 100 years. Sedimentary rock covers high mountains and the highest of all, the Himalayas. Shells and skeletons of sea animals are found there. This means that at some time fish swam over these mountains. What caused the mountains to rise? A force pushing from within or pulling from without or twisting on the sides must have elevated the mountains and lifted continents from the bottom of the sea and submerged other land masses. If we do not know what these forces are, we cannot answer the problem of the origin of the mountains and of continents wherever on the globe we are faced with it. Here is how the question is put concerning the east coast of North America. Excuse me. Not long ago, in a geological sense, the flat plain from New Jersey to Florida was under the sea. At that time, the ocean surf broke directly on the old Appalachian Mountains. Previously, the southeastern part of the mountain structure had sunk below the sea and become covered with a layer of sand and mud, thickening seaward. The wedge-like mass of marine sediments was then uplifted and cut in two by rivers, giving the Atlantic coastal plain of the United States. Why was it uplifted? To the westward are the Appalachians. The geologist tells us of the stressful times when a belt of rocks extending from Alabama to Newfoundland was thrust together to make this mountain system. Why? How was it done? In former times, the sea flooded the region of the Great Plains from Mexico to Alaska and then withdrew. Why this change? The birth of the Cordilleras. Again, the mystery of mountain making clamors for solution. And so on all over the world. The Himalayas were under the sea. Now Eurasia is 3 miles or more above the bottom of the Pacific. Why? The problem of mountain making is a vexing one. Many of them, mountains, are composed of tangentially compressed and overthrust rocks that indicate scores of miles of circumferential shortening in the Earth's crust. Radial shrinkage is woefully inadequate to cause the observed amount of horizontal compression. Therein lies the real perplexity of the problem of mountain making. Geologists have not yet found a satisfactory escape from this dilemma. Even authors of textbooks confess their ignorance. Why have sea floors of remote periods become the lofty highlands of today? What generates the enormous forces that bend, break, and mash the rocks in the mountain zones? These questions still await satisfactory answers. The process of raising the mountains is supposed to have been very slow and gradual. On the other hand, it is clear that igneous rock, already hard, had to become fluid in order to penetrate sedimentary rock or cover it. It's not known what initiated this process, but it is asserted that it must have happened long before man appeared on the earth. So when skulls of early man are found in late deposits, or skulls of modern man are found together with bones of extinct animals in early deposits, difficult problems are presented. Occasionally, also during mining operations, a human skull is found in the middle of a mountain under a thick cover of basalt or granite, like the Calaveras skull of California. Human remains and human artifacts of bone, polished stone, or pottery are found under great deposits of till and gravel, sometimes under as much as 100 feet. The origin of clay, sand, and gravel on igneous and sedimentary rock offers a problem. The theory of ice ages was put forth 1840 to explain this and other enigmatic phenomena. As far north as Spitsbergen in the polar circle, at some time in the past, coral reefs were formed which do not occur except in tropical regions. Palms also grew in Spitsbergen. The continent of Antarctica, which today has not a single tree on it, must have been covered at one time by forests since it has coal deposits. As we see, the planet Earth is full of secrets. We have not come closer to solving the problem of the origin of the solar system by investigating the planet under our feet. On the contrary, we have found many other unsolved problems concerning the lithosphere, hydrosphere, and atmosphere of the Earth. Shall we be more fortunate if we try to understand the process that caused the changes on the globe in the most recent geological epoch, the time of the last glacial period, a period close to the time which is regarded as historical?